chapter concept of stability and Rouths stability criteria. So this is the first class of Rouths stability criteria and concept of stability, and we are now we will see some questions, some previous year questions which were asked in GATE. So the first question is, in the formation of a Rouths Hurwitz array, all the elements of a row have zero values. This premature termination of the array indicates the presence of, there are four alternatives given, and this question has been asked in GATE 2014 S1. Here it is given that all the elements of a row, have zero values. So this is the difficulty number 2 of Rouths stability criteria. And why this difficulty arises? This difficulty arises due to presence of symmetrically located root. And now what is symmetrically located root? Symmetrically located root means if there is a pole on positive real axis, then there must be a pole on symmetrically, there must be a symmetrical pole on negative real axis. Suppose if there is a pole on imaginary axis, positive imaginary axis, then there must be a pole on negative imaginary axis. Suppose there is a pole, there is a complex pole in first quadrant, then there must be the pole in all the quadrants at same distance and at same relative location. So what is symmetrically located root? There are three types of symmetrically located root. Let me discuss what is symmetrically located roots. Symmetrically located roots. So first type of symmetrically located root is like this. This is S plane. Suppose there is a pole at negative real axis. So there must be a mirror image on positive. There must be a pole at mirror image on positive real axis. This is real axis and this is imaginary axis. So this is first type of symmetrically located root. This is type 1. Type 2. Suppose there is a pole located on imaginary axis. Suppose here there is a pole here. So there must be a pole on at the there must be a mirror image of pole on negative imaginary axis. This is also symmetrically located root. Type 3. Type 3. So type 3 is, this is also S plane. Okay, here S plane. There is a pole, suppose here. So there must be a pole at mirror image along real axis and mirror image along imaginary axis also. So there must be 4 poles, 1 pole in each quadrant. This is real axis and this is imaginary axis. So if all the elements of a particular row in Rouths array is 0, this only indicates that there exists any one of the three conditions. Either the poles are symmetrically located on real axis, or the poles are symmetrically located on imaginary axis, or there exists a quadrupole, means the pole is symmetrically located in each quadrant. These two are called dipolar condition, and this is called quadrupole condition. So let us see which one is correct. So first alternative says that only one root at the origin. This is not possible because there must be any one of the three cases. So imaginary roots. Okay, there may be imaginary roots like this. Only one positive real root. This is also not possible. If one positive real root exists, then there must be some negative a negative real root at a symmetrically located negative real root. Only negative real root. This is also not possible. So only possible answer is answer number B, imaginary roots. Next question is the first two rows of Rouths tabulation of a third order equation are as follows. S3 and the two rows S3 and S square are given. This means that there are four alternatives given, and this question has been asked in GATE 2009. So it is given that S3 Rouths array, the two rows S3 and S square. So it is 2, 2, 4, 4. Now what will be the next row? So if we calculate the next row, then S1 will be equal to how we calculate the next row? We have to multiply this 4. This 4 gets multiplied by 2. This 4 gets multiplied by 2, and this 2 gets multiplied by 4, and then this 4 gets multiplied by 2, and 4 gets multiplied by 2, and then 2 gets multiplied by 4, and then we have to subtract these 2. 2 gets multiplied by 4 divided by this 4. So how much it will be? So it will be nothing but it will be 0, because 8 minus 8, it is 0. The next term will be nothing, because here there is no term. So 4 multiplied by 0, so there is no next term. So S1 has only one term, and that is 0. So here the difficulty due to Rouths difficulty arises, because if we calculate the next term, that is s to the power 0, this term, then what will happen? This 0 gets multiplied by 4. So in this case, what we do? This 0, let me indicate this like that. This 0 gets multiplied, and here this 4 gets multiplied by, since here there is nothing, so we take this as 0. So here also we take as 0. So what will happen? So 0 multiplied by 4, 0 multiplied by 4 minus 4 multiplied by 0. Here there is no term, so we are taking it as 0 divided by 0. So it will be 0 by 0. That is not defined. 0 by 0 is an indeterminate term. That is indeterminate term. This is a indeterminate. So this is an indeterminate term. So now here the Rouths test breaks down. We cannot proceed for Rouths test. So what we have to do here? We don't. If we get all the elements of a particular row, if we get all the elements of a particular row of Rouths array 0, then we have to stop there. Here also all the elements. Here also all the elements of the row s to the power 1 is 0, because it has only one element and that element is 0. That means all the elements of row s to the power 1 is 0. Now what we have to do? We have to make the equation from the elements above that row of zeros. This is the row of zeros. We can say this as the row of zeros. This is the row of zeros. This is nothing but row of zeros. So now what we have to do? We have to make the polynomial from the elements just above the row of zeros. So this is row of zeros. So just above this row, the row containing s square is there. So we have to make polynomial from the elements of row s square. So what will be the polynomial? The polynomial will be the polynomial from the elements of row s square will be, what will be, 4 s square plus 4, because here it is 4 multiplied by s square and this is 4 multiplied by s to the power 0, that is 4. So this polynomial, if we make the polynomial from just the row above the row of zeros, then this polynomial is called auxiliary polynomial. This polynomial is called, what is called, auxiliary polynomial. So this is called this is called auxiliary polynomial. Here one thing you have to notice, that auxiliary polynomial always remains in even order. It never remains in odd order. Means the degree of auxiliary polynomial is only even. It never remains in odd order. So let me write this point also. What is the property? This is the property of auxiliary polynomial, that the degree of auxiliary polynomial always remains even. Now this auxiliary polynomial, if we express this in equation form, then it will be 4s square plus 4 equal to 0. Then that equation is called auxiliary equation. If we express it in polynomial form, then it is called auxiliary polynomial, and if we express it in equation form, then it is called auxiliary equation. So here let me write, if we express in equation form from the coefficients of from the elements, if we express in equation form from the elements of row just above the row of zeros, then that equation is called auxiliary equation. Then that equation is called auxiliary equation. Okay, now I think it is clear to all of you what is auxiliary equation and what is auxiliary polynomial, and what is the difference between auxiliary equation and what is the difference between auxiliary polynomial. Yes. So here the auxiliary equation will be, here in this case, here equation is, what is auxiliary equation? Here it is 4s square plus 4 that equal to 0. Now what is the importance of this auxiliary equation? So there must be some importance of this auxiliary equation, as we have discussed in the previous problem, that if all the elements of a particular row of Rouths array is 0, then it only indicates that there exists some symmetrically located roots, and if we determine the roots of auxiliary equation, then that will give those roots which are symmetrically located. So now we have to solve this equation to get the symmetrically located roots. So let me wipe out this and then we will solve it. So here the auxiliary equation is 4s square plus 4 equal to 0. This means s square is nothing but minus 1. This only means that s equal to plus minus j1. So these are symmetrically located roots and these roots are on imaginary axis. So we have got two roots of the system which are located at plus minus j1. Now we have to again form the Rouths array by making some modification. So how we have to form, let us see. Previously it was s cube s square, and these the terms in the row s cube were 2 and the terms in row s square were 4 and s1 was becoming 0. So we don't have to write s1 equal to 0. Now we have to form the auxiliary polynomial. So what was the auxiliary polynomial? So auxiliary polynomial is as equal to 4s square plus 4, as we have seen so now what we have to do, we have to differentiate this auxiliary polynomial and then we have to replace the element of the row of zeros. This was the row of zeros by the coefficients of the element of the row which is coming after differentiation of this auxiliary polynomial. So let us differentiate this. So after differentiating this auxiliary polynomial, it comes 8s, only 8s. So now we have to replace that this row of zeros by the coefficients of this polynomial. That is the polynomial coming after differentiating the auxiliary polynomial. So now the coefficient of s is 8. So we have to write here 8. And after writing the elements of row of zeros, means after replacing the elements of row of zeros by the differentiation of auxiliary polynomial, now we have to carry out the Rouths stability test as usual. Now s to the power 1 will become 8. So the next row s to the power 0 will be, we have to calculate s to the power 0. So now we have to multiply this 8 by 4 and here this 4 by here, since there is no element, so here it is 0. So now the element in s to the power 0 will be, what will be? 8, this 8 gets multiplied by 4, this 4 minus this 4 gets multiplied by 0 divided by this 8. So how much it will be? It will be again 4. So it will be 4. Now we have to see the first column of Rouths array. This is the first column of Rouths array. This is the, let me denote it by blue. So this is the first column of Rouths array. This is the first column of Rouths array. So now we have to see for sign change in first column of Rouths array, whether there is any sign change or not. So now we can see that this is plus 2, this is plus 4, this is plus 8 and this is plus 4. So there is no sign change in first column of Rouths array. So except these two symmetrically located roots, there is no root, or you can say there is no pole in right half of S plane. So since and also the characteristic equation is of third degree, because here the Rouths array starts with s to the power 3. So there must be 3 roots, and 2 of them are at imaginary axis at plus minus j1, and the third root will lie on left half of S plane, that is on negative real axis. So 2 roots. So the conclusion is 2 roots will lie on imaginary axis, that is plus minus j1, and 1 root will lie on negative real axis. So which option is correct? 2 roots at S equal to plus minus j and 1 root in left half of S plane. Okay, left half of S plane. So and let me see whether any more appropriate answer is there. 2 roots at S equal to plus minus j and 1 root in left half of S plane. So both of the answers are the same. So we can take any one of the answer as true, or we can change one alternative. 2 of the roots are at plus minus j and 1 root in left in place of left. If we write it in right, then there will be only one option correct, and that option will be option number D. So if we make right in place of left, then this option will also be incorrect. Why I have made this change? Because both A and D are same. So but there in gate there is only one answer remains correct, and since both answers are same, so we have to make this change. I think that this must not be the alternative. The alternative must be in these two alternatives there must be one alternative must contain right half and one alternative must contain left half. So if we make alternative number A as right, then our alternative number D will be correct. Now at the last of the lecture, I would like to share one of the most important thing to you people, that if you like my video, then you must subscribe my video, so that there is no need to search out new video. Automatic update will come if I upload the new videos. What you have to do, it is very simple. There is a circular logo coming in right of me. You have to just click on that to subscribe.